Okay, so we go summary about this topic. So what in this topic you have two type of data. Okay, dual journeys data, whether it's discrete or continuous. So this one you have to really clear about the type of data. Your data might be discrete or continuous. So itu adalah sifat-sifat data kita lah. Okay, sifat-sifat data kita iaitu maksudnya bila kita ambil data, kita boleh tengok data ni jenis macam mana, jenis satu-satu ke jenis yang ada continuous. Continuous maksudnya it is in in a interval, ada decimal, so dia bukan discrete satu-satu. So discrete is like nombor bulat. So like dia tak ada kuantiti di perantaraan. Okay, contohnya kalau you ambil data dalam bentuk blood type, discrete lah. O is O, A is A. You won't have between OA. If you take the data is about height, yes, it will be a continuous, because when you take this height, you get 100, 1.54, some is 1.54 meter, ada decimal lagi. So dia ada nilai-nilai perandaan. Itu jadi continuous. Okay, so start from chapter 6 to chapter 10 is about statistic view. It's about talking about our data, how we analyze our data, how we calculate our data, then how we use that information to know our uh, analysis, to know our details, what's the data they want to tell you. So you have to undergo analysis and get it to a clear situation. And okay, so that is a type of the data. You have discrete, you have continuous, and then sometimes what we collect our data is come from population. Population means overall. Overall, you take overall sample. Like what is the difference between population and sample? Population means you will take everyone, take in count every element, all the elements that you want to study, but sample is a part of it like that. So like you want to study like student of matriculation. When we talking about population, means you have to take the whole Malaysia uh, about about our objective, our student of our matriculation. Population means every lah, daripada Perak ke lain semua ambil. So population, whole group. So a sample means maybe we just take from Perak saja, like that. So if you see how you want to find your data, it is depends on how you want to target your data. So from where you want to calculate your data, from where you want to get your data, from population or from sample. So like sometimes you want to say we want to analyze result. So if population means result, the whole matriculation result. So we have many, we will have a lot of data. So if we take a sample, maybe we take a one class, we analyze a sample from one class, how's their result. So that's just a sample. So from where we get our data, so we will review. Okay, we will need to know our data come from population or we come from sample, because our parameter means pengiraan kita. Our parameters such as what we want to calculate, mean, mood, median, all that is our parameter. Parameter means something you want to use to measure our population data or sample data. Okay, our parameter that we use in population will be different. Like mean, although we call mean, but their symbol is different. For sample, mean we will write like this, x bar, but for population, we'll write is in mu, so that will our parameter of our mean. So variance also different. Okay, population variance you will write in sigma square, but in sample you use in s square. So last time your SPM is learning about variance for population. So now we're going to learn about variance for sample. So there are difference. Okay, they are definitely different. So when there are variance, there are different symbol. our standard deviation also will be different. So this is our standard deviation, which is sigma only. Then sample for standard deviation, we S only. So when we get our data from sample, we want to calculate mean. So we cannot use a wrong symbol. We calculate mean, you write this, so definitely we will deduct your marks, okay? And then when you say you want to calculate your variance for sample, and then you go to use this symbol, so it will be a wrong. Okay, definitely a wrong concept. Although your calculation is correct, but it doesn't make sense. Means you are not understand what you are doing. So that will be parameter for population, parameter for sample. It will be different. Okay, there will be difference. So now you're going to see a lot of mean like this, but you never see your mean in like this. Last time your SPM mean is like this, but you didn't meet your mean in mu form. Okay, last time you meet your standard deviation and variance in this form, but you didn't meet your standard deviation in this. Okay, so later on you can see your formula also different when you're doing sample and population. So this is what we call parameter. One of our parameter, we have a lot of parameter we can calculate on our data. So on our data, discrete and continuous, you have to know your data. Jenis dia discrete ke continuous, because it is very important. You want to represent your data. How is it? Is it you're using group data, or are you using ungrouped data? Okay, so discrete normally countable lah. Alright, discrete normally countable means 1 is 1, 2 is 2. You will not have intermediate value. So continuous data normally is come in interval. So means your value will be like, when you're talking about height, you will consider about decimal. So that will be like you have intermediate mediate value. So it will be a continuous data. When you're talking about your mass also, okay, when you're talking about your quantity of area, so all this data is about our quantity. When you're talking about area, when you're talking about your time, or you're taking when you're talking about volume, so that will be under continuous data. So discrete normally like the number of students, the number of car, the blood, okay, the gender that cannot mix. Boy is boys, girl is girl. It cannot be intermediate. Ada tengah-tengah, boys tambah dengan girls tengah-tengah, half-half. You wouldn't be like that. So discrete data is one is one, another is another. You will not have intermediate. Nilai tengah-tengah macam tu. Okay. So of course, when you get all this data, it can be represent in group data or represent in ungrouped data. So you will have two type of data. Okay, so one is ungrouped data. Another one is group data. So the difference in ungrouped data is group data. Ialah group data, they will give you a class interval, where you will see an interval means your data like 3 to 5 like that, the interval data. So that will be a group data. So ungrouped data, it can be written 3, 4, 5, 3. They can put a list like that. They also can put in table like your data is 3, then your data is 4, your data is 5. So X is represented by our data. So your frequency means your occurrence. Kewujudan dia 3 ada 2 kali, 4 ada sekali, 5 ada sekali. So this kind all is ungrouped data. So group data, it will have interval like interval 3 to 5, and then 6 to 9, like that. So you cannot identify what is your data in the middle here. But group data, you can clearly see what's your data number one by one. Okay, so that will be our two type of representative of the data, ungroup data and group data. Then we can go for the first parameter. We are going to measurements about location. So what is mean by measurement about location? We will be going to calculate what's your mean, what's your mood, what's your median, what is your quota. All these, they will need to identify your location first. Then only you can calculate out what is your value, what's your analysis result. Okay, so measurement about location means you have to identify the location. You gonna identify its position. Then only you can get to the result. So that is the mean by measurement of location. So the parameter, benda yang kita nak kira adalah ada apa? Ada mean. So measurement of location. The first one you can calculate about your mean. Okay, so your mean. So this is our sample mean. Yeah, this is our sample mean. So ini nama dia, ini simbol parameter kita. So for ungroup data, when we want to find mean, how we going to calculate that? We are going to sum all of your x divide by of your number. So if you get your data like this, they give you a list. You just sum all your data and then divide how many data of it, n is number. But sometimes your data will come with frequency like this part. So you're going to your data time with your frequency, then divide by its frequency, because when you divide by its frequency, here already represent the number of data already. So you have to times, because this is understood that 3 you have 2, so you want to total up is 3 times 2. 4 you have 1, so you times 1. 5 you have 1. Then this is how you total up your data, and then divide by its number of data. So this is your formula for your ungrouped data. But for your group data, so your group data will be having similar formula, but their usage, they are different. For mean, as you can see your mean here, they also same. They will go into sum of fx over sum of f. So but the x here, because you don't have a data here, so the x here is represent your midpoint from your class interval. So you can see your class interval here. So how to represent your data? We'll take your midpoint from your interval. So that will be the difference between, you can see, ungroup data and group data for the first measurement about your measurement of location, which is mean. Then you can move on when you measurement of location also can finding about mood. So mood, it will be in the symbol of like this. Okay, a bit like unit vector, but this is not vector. Kalau vector dia ada ekor di bawah, so dia bukan vector, dia mode. Tajam macam ni lah. So mode will be simple because mode will going to see the highest occurrence data. Okay, the value that occur the most frequently. The data that occurs most frequently. So means that you can see your highest, the frequency, mana yang paling tinggi, itu yang dia berlaku paling kerap. So itulah mood kita. So kalau ikutkan data ini, mood kita 3 lah. Okay, tapi untuk group data, mood dia lain. So group data, we have their formula to go. So we go for our ungroup data first. So mood, cari with the highest frequency. Look at the data with the highest frequency. And then continue. What can you calculate some more? Your median. So your median is like this. Okay, gelombang di atas median. So your median in matriculation, they will not going to use like your SPM about odd even. So don't do that. Okay, I remind you, don't use the method saying odd number, so how to calculate even number, how to calculate. Don't do that. It will be a wrong concept, because in your syllabus, median is calculated by using the method like quartile, percentile. Okay, what they want you to do is you have to understand the formula like this. The data S plus the data x plus 1 over 2. What's mean by this? The data x. Okay, so we read the explanation about the s. S is about the integers. So what is your s here? So your s is your location, because apa yang kita kira sekarang is about measurement of location, like mean. Mean adalah jawapan kita purata, overall purata. Maksudnya purata dia boleh macam jadi average tengah-tengah macam tu, average result. So mode, you punya analysis data berada di the highest frequency, so you still affected by the location, tempat dia. Tempat dia main peranan. So macam di tempat highest frequency, itulah data kita. Yeah. So median X2 adalah your bilangan data bahagi 2. Okay, S adalah you punya bilangan data bahagi 2. Kotak kotak data itu bermaksud apa? Kotak data itu bermaksud kita akan kita ambil integers, the least integers greater than your value, S. So let's say you have 3 data. Okay, let's say you have 3 data. When you have 3 data, you want to take median, you are going to find the location in the mid, in the center. Right? So you're going to divide by 2. So you get 1.5. So means that your S is 1.5. Okay, so what's your integers? What's the integers? The least integers that greater than S. Nombor bulat yang paling kecil tetapi kena besar daripada 1.5. So your least integers is 2. So your least integers is 2. Okay, so when your S, you can see when your S, bila dia bukan integers, kalau kita dapat keadaan ini, 1.5 is not integers. So integers is your SM1 topic 1. What is integers or is not integers? When you get your S where it's not integers, we just read the data come from the least integers greater than X, means you're going to read the data number 2. Okay, because when your S is not integers, you're going to read the data number 2. But let's say, for example, my data is 4 data here. You can see if we have 4 data here, we're going 4 divided by 2. It will be equals to 2. So when we having our location at 2, which is a integers, how we going to read our data? Which is that data, okay, that data and the following data divided by 2. So from here we can see it is nothing regarding your odd even things. Okay, nothing even your odd even things. It's about all your S. How you're going to find your S? Is it integers or not integers? If not integers, data yang seterusnya. Okay, data yang seterusnya. Kalau 1.5 maksudnya data nombor 2. Kalau kita dapat integers, kita tahu okay, data yang sedia ada, data nombor 2 dengan data yang seterusnya. So bila kita nak ambil keadaan ini, so kita akan ambil data nombor 2 tambah data nombor 3 bahagi 2. So kalau kita dapat keadaan S is not integers, kita akan ambil data nombor 2. Beginilah kita cari median. So ini adalah konsep percentile. So if you notice that your quartile, your percentile, all in the same formula like this. Just when we move to quartile, uh, Q1, the location is different. So Q2 will be same as median. Q3, location difference. Location difference. So their location, where's their location? So your location will be like usual. When you want to find quartile number one, automatic you are going to do your number of data divided by 4. When you want to find your data for third quarter, you're going to find 3n over 4. So this is your S. Find your location first. So when you get your location, then only you can determine which data that you're going to calculate to get that median, to get the first quarter, to get the second quarter. So for quarter, they're still using the same. Okay, they're using the same formula. So means when your location is non-integers, kita akan baca data untuk integers yang seterusnya, iaitu 2. Kalau kita dapat location kita adalah integers, maka kita akan baca data untuk tempat tersebut dan seterusnya, the next coming integers. Okay, so if you see your percentiles, they are also same. If you see your percentile, so depends on which percentile you want to calculate. Depends on which percentile you want to calculate. If you want to calculate like percentile 81, so it will be 81 per 100 times our data. So you want to see how many percentage. You want to see 57 percentile, so it will be 57 per 100 times your data. So depends on which part you're going to analyze your data here. So you can notice that measurement of location or is talking about tempat. You need to find out the place first, then only you can read out the data. Okay, you cannot directly read the data straight away. So that will be our measurement of location for ungroup part. So for group part, there will be difference. Okay, their formula will be different. So for group part, just now you can see when we're doing mean, they were going sum of fx over sum of x, sum of f. So x is represent your midpoint. So you just think logically, because when we have a class interval, we cannot see what's your data. Bila kita ada data 3 ke 5, so what's your actually what's your data? We don't know. So to represent the data 3 to 5, we take the midpoint. To represent the data for this group 6 to 9, we take their midpoint. Okay, so their mean will be like this. So when they go for mode, so for group data, everything is formula. For mode, they are going to use their lower boundary plus B1 over B1 plus B2 times C. So of course, you have to identify where's your mood class first. What's your mood class? Because you just bear in mind, measurement of location, you kena cari tempat dulu. Ini cari tempat data yang ke mana. Ini kena cari kelas yang ke mana. Mood class yang mana. So this will be the difference before the mood class, and then this is the difference between mood class and the class after that. So C you don't calculate with your fingers. C, please use back upper boundary minus lower boundary. Okay, your SPM data would not as nice as our matriculation data. So your SPM punya data dia memang dah cantik dah. Sebenarnya kita ada berbagai data, dia takkan cantik macam tu. So you kena tahu kalau jumpa data yang tak cantik, nak kira macam mana. Okay, and then L is stand for lower boundary for that class. Okay, identify the class first, find their difference, find their upper boundary minus lower boundary. So use substitute your data inside. That will be your mode. And then median. So their formula similar. L plus just this part. The bracket part will be different. Here will be n over 2, the allocation, minus the cumulative frequency before that, and then divide by its frequency. Okay. So you need to find out your median class first. Okay. Find out your median class, where is your n over 2 located. Find out that class, find its cumulative frequency before, then its own frequency. So this is your SPM. I believe this one you see it before, you done it before. And quartile also same. So depends on your quartile. If your quartile, you have to bear in mind, second quartile nombor 2 ni, Q2 ni adalah sama dengan median. So Q1 and Q3 is different. So if you want to find your Q1, okay, so their formula will be similar. Still lower boundary plus n over 4 divided by f over f. The location is different only. Where when you want to find median, you find for median class n over 2. You want to find for first quartile, you're going to find n over 4, find its class first, then use the class and calculate, put in this information. If you want to find for third quartile, then you 3n over 4, find that quartile class first. So actually this topic is all using formula. It depends on how you're going to use your formula. So percentile, okay, percentile still same. Lower boundaries, then depends on which percentile you want to find. So which percentile per 100 times your n. Then minus your cumulative frequency before that. So same. Okay, their formula similar, just inside the bracket here, difference by its position. Okay, so we go for part number 3, 6.3, about measurements of dispersion. When you're talking about measurement of dispersion, means perbezaan antara data. Okay, so tadi location kan. So location, when you calculate all these parameters, you need to find out their locations. Then only you can find out what's the data that hold for that location. But when we go for measurement of dispersion, you're going to calculate the difference between the data. Their differences. How their varies. Macam mana mereka berbeza antara sesama sendiri. Berapakah perbezaan? So, what do you learn is, you learn your, in the quartile range, so you learn your range. So range is your SPM part lah, where you how to find your range. So for ungroup, just the highest minus the lowest. So for group data, it won't have the highest value and lowest value, so it will be the highest midpoint minus your lowest midpoint. So this is your differences between your data. Then you can find your interquartile range. So this is one part of our measurement dispersion. It will be Q3 minus Q1. So formula will be same, but how you get your Q3 and Q1, there will be difference for ungroup part and also for group part. Okay, then variance Okay, variance, as I said, variance just now. So for our part formula that we learned, that it will be your sample variance. It's not population value. So don't use don't use this symbol. This is population variance. This is population variance. This is sample variance. What we calculate now is sample variance. So you can notice that your formula will be different from your SVM that you learn your formula. So for ungrouped data, your variance will be sum of x squared divided by minus sum of x squared over n, then divide by n minus 1. So normally we don't want to make this complicated. We will do like this 1 over n minus 1. We don't want over something. Sum of x squared minus sum of x squared. So that will be our variance. Okay, so this is our variance. This means by our data square first, then total up. So you must know how to read your formula. This is mean by our data total together, then after it only we square the total. So it will be difference. We square the data and total, or we total up and square after that. So sometimes our ungrouped data it will be having frequency. So when you're having frequency, it will be no problem. You will still see sum of fx squared. So means that you square first your data, then you time your frequency. Minus here sum of fx squared over sum of f. So when we go for standard deviation, which is s, so we are going to square root. The relationship between square root and s square and s, variance and standard deviation, they just square root and square only. So variance got square, so standard deviation you will be going to square root your variance. So when I go for part group data, their formula are similar. We just don't have this part only. We didn't have this because group data always got frequency. So their variance 1 over n. So in bracket, sum of fx squared minus sum of x over sum of f. So come to standard deviation, it will be under the square root. Okay, so this part, no matter you are calculate range or you calculate your in the quarter range, your variance, your standard deviation, your result. So if your result you're getting a very big value, okay, means that your data will difference a lot. So that will be what we understand from our calculation, what is our interpretation on our data. Okay, so in other words, we can say that your data is not consistent when you're getting a very huge value of range, huge value of standard deviation, huge value of variance. Okay, so when you look at your quiz 1, quiz 2, quiz 3, your result, you can see your result 90 something, 90 something, 90 something. So your difference through your standard deviation and variance will be very small value. But if your quiz 1, quiz 2, quiz 3, suddenly 90 something, suddenly 20 something, and then suddenly 30 something, so you can see your 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 data is going inconsistent, up and down. big value, small value, big value. When you calculate their standard deviation, of course you will get a very big, okay, very big difference. So this is how the measurement of dispersion tell us the story of your data. Okay, so when you're doing all this, when you're doing this data, it also involving like your experiment, everything. So therefore, when you're doing your lab, doing your experiment, when you calculate your result, then you know you are doing your experiment correctly or not. How come your data it become so huge, so different? Why come your error so big, like that? So that will be our use for our this all parameter. Then we can query you about your data, how you get your data come from. Is it any step that you do it wrong? Okay, so beside we learn the measurement of location, the measurement of dispersion. What can we in this topic? You have a lot of representation of your data. Okay, you learn how to draw your stem and leaf. When you get your data, stem and leaf, you draw your stem and leaf, and then you draw your box and whisker. So of course, when you have drawing, then it will be easier in analyze our skewness, our distribution. When we're talking about distribution part now, so for distribution part, so you will have three types of distribution of your data. So one is symmetrical distribution, another one is, or we call it bell shape, symmetrical distribution, or we can call it bell shape, or we can call it normal. So this one you will use a lot for the topic at the back. Okay, sometimes you can get your data skewed to the right. Okay, or you can get your data skewed to the left. So when you draw your stem and leaf, when you draw your stem and leaf, when you have distribution, symmetrical distribution, you can see your stem and leaf. Okay, all your leaf is here. Then you can see your distribution is curved. Okay, I draw the symmetrical distribution means you can see your data is distributed left, right, balanced. When you say skewed to the right means your data is going to prolong to the right hand side. Okay, and when you say it's skewed to the left means your data is prolonged to left hand side, means prolonged to the smaller value. Here is prolonged to the large value. What's mean by this? Means you can see if we talking about result. Okay, talking about result means a lot of among yourself getting very low result, but got one or two people is very high result. So they will skew the data to the right. So what is mean by skewed to the left means maybe a lot of people is getting very well. This might be this might be only this might be your SEM one result. A lot of people getting very well result, but still got in the class still got that 1 or 2% that didn't study one they will skew the result to the left because their result will definitely very obviously or is extremely low. So that will be our the meaning of skew to the left, skew to the right, and normal distribution. Normal distribution means normally people are scoring 50 something, 60 something like that. So a few people high marks, a few people low marks like that. So this is normally normal distribution, skew to the right and skew to the left. So when you're doing your stand and lift, you can see it uh, in uh, uh, in side view like that. So if you see if your data is occur like that, then skew to the skew symmetrical skew. If you going to skew to the right means you can see your stand and lift. You're going to higher this part and then drag it to the higher value. So if you drawing your stand and lift, you can see your value here is smaller value is a few, normally all at higher value. So skew is going to see your graph is prolonged. Skip bermaksudnya tempat tarik, bukan tempat yang tinggi sana. So ditarik ke kanan, ditarik ke kiri. So if box and whisker, you're going to see within your box. Symmetrical box, kiri kanan sama besar. Kalau skew to the right, bahagian kanan lagi besar. Kalau skew to the left, your distribution, bahagian kiri lagi besar. So your box and whisker here represent your Q1, Q2, Q3. Q1, we're just referring to your box. We're not going to referring to your whisker to identify your distribution. So beside that, beside from the stem and leaf, you can know your distribution. Box and whisker know your distribution. Okay. Beside that, from your mean, mode, median. For your mean, mode, median. After you calculate your mean, mode, median from your data, when they are equally same, you can justify your data. They are symmetrical distribution. Okay, so when they are equally same, but when you calculate your mean, mode, median, sometimes within same, it will be your mode less than your median, and then less than your mean. This one will be your skew to the right. Okay, and then for skew to the left, your mean will be smaller than your median, and then smaller than your mode. So we have one method one, method two. No, we have one way to identify. This is one, this is two, this is number three. Third way to identify the distribution, and another, the last way is using your calculation, which is person skewness of coefficients. So that one is totally depends on our calculation. Person coefficient of skewness. So it will have two formula. Okay, depends on what kind of parameter you want to calculate. They have two formula. So the first formula they are using mean and median. So divide by standard deviation. So another person coefficient of skewness is using our mean and mode. Mean minus mode divide by its standard deviation. Of course, when we have difference formula, when you use your difference formula, our result will be different. But our justification, our distribution will go into the same. Okay, so it will be definitely if symmetrical Okay, so this is our guideline. If 0 means your distribution will be symmetrical. So this side onwards will be positively skewed. And then less than 0 onwards will be negatively skewed. So percent coefficient is totally depends on the reading. Okay, so this also depends on reading, but this two is depends on drawing to identify our distribution. So of course, when you come to very near to the 0, we can say our distribution approximate normal. So very near means 0.00 something. It's very hard to get a reading of 0, but most probably will get 0.00 something. Then we can see that data distribution is approximate to normal.